Okay. Number one, AB and PQ are corresponding sides. AB, PQ, BC and QR, CA and RP. Corresponding angles are angle A and angle P, angle B and angle Q, angle C and angle R. Number 2, side DE and side HJ. They are corresponding sides. EF and JK. FD and KH. Corresponding angles are angle D, angle H, angle E and angle J, angle F and angle K. Number 3, 3.125 feet. 3.125 feet. Number 4, 13.33 repeating centimeters. 13.33 repeating centimeters. If you don't have your homework, you're writing the answers down right now. So when you do your homework, you can answer, you can have the answers. Melissa, get a piece of paper out, you're writing the answers down. Jack, you're writing the answers down. Okay, if you don't have your homework, you're not off the hook. You're not sitting there doing nothing. Number 5, 80 inches. And by the way, I say the same thing every single day for people that don't have your homework. That should be a given, that you're writing the answers down. So number 5, God bless you, is 80 inches. Number 6 is 40 meters. Number 6 is 40 meters. Number 7, 20.25 centimeters. 20.25 centimeters. Number 8, 7.2 feet. 7.2 feet. Are there any of that grouping 1 through 8 you need me to repeat the answers to? Okay. The next one is 23. 23, part A, this is the sample answer. GK and RQ are not corresponding sides. Come on. You guys are on 23A. GK and RQ are not corresponding sides. That would be an example of his error. What proportion should he have used? All right, one of the proportions he could have used is GH over PQ is equal to HL over RQ. That's one of the proportions he could have used. We can look more into that one if there's other ones you had. Number 30. 30A is 6 meters. 30A is 6 meters. 30B, the perimeter of the small one is 6 meters. The perimeter of the big one is 18 meters. So that's 6 meters and 18 meters. C said, is the ratio of the perimeters of the rectangles equal to the ratios of corresponding sides? So you needed to set up the ratios of the perimeters and see if they're equal to the ratios of the corresponding sides. And the answer is yes, they are. Part D, what is the area of each rectangle? The small one is 2 meters squared and the big one is 18 meters squared. So 2 meters squared and 18 meters squared. All right, 36 was a challenge problem. All right, so this one may have been a little bit more difficult. All right, but I would expect you to do this problem because I am giving you a problem like this on a test or a quiz. So put a big fat star, number 36. All right, because we did the other ones in 7th grade. Now that we're in 8th grade, we're going to do a little bit more challenging ones. So for part A, the proportion would be 8 over 8 plus x is equal to 5 over 7. 8, come on, everyone's looking at your answers. 8 over 8 plus x is equal to 5 over 7. Part B, x is equal to 3.2. X is equal to 3.2. Part C, AB is 11.2 inches. 11.2 inches. The area of the triangle ABC is 39.2 inches squared. 39.2 inches squared. Are there any answers you guys need me to repeat? Okay. Are there any of these that you guys would like me to do for you before we start with our next section? Kaylee? Number 5? Okay. So let's take a look at number 5. So number 5 had 2 rectangles. All right, and I do recognize that they didn't always give you the letters that go at the corners. You could certainly have come up with your own letters that go at the corners. Or when you set up your proportion, you could just start with the numbers. That's up to you. They tell us that these are rectangles. They give us a big one and they give us a small one. All right, so they tell us that the right side of the big one is 18 inches. The top is 120 inches. Then they tell us the right side of the little one is 12 inches and the base is 10 inches. And they're telling us to find x. Okay, well, let me ask you something. On our big one, our big rectangle, what do we know? Well, on rectangles, what do we know about opposite sides? So opposite means the top and the bottom. Opposite means the right and the left. What do we know about opposite sides? Melissa? They're always the same. So while x is that bottom side, that is the same thing as the top side. Where the 120 inches is the top, the bottom is exactly the same. All right, so here are our corresponding sides. So I'm going to go ahead and write my proportion. So I have 18 over 12 is equal to 120 over x. I'm using them using corresponding sides. If I wrote these using the same shapes, so the sides with the same shapes, I would have 120 over 18 is equal to x over 12. Either one of those two or the reciprocals of all of that. So these are your proportions that you could have. And if you notice when we do cross multiplication, they're exactly the same after that. So I have 18 times x is equal to 120 times 12. Now you could have divided out common factors between the 18 and the 12 if you wanted. I just wanted you to show that these two would be the same thing. All right, so if I have 120 times 12, I end up getting 1,440 is equal to 18x. Divide each side by 18, and I get x is equal to 80 inches. Kaylee, does that help you? Oh, okay. What else can I do? Lily? 36. So the key to doing number 36 is to picture them as completely separate triangles. And I would highly recommend that you draw them as separate triangles. So I'm going to start with my given. All right, and then that goes there. All right, so here are my triangles. I have A, B, BC is my big triangle. These are both right triangles. And then I have this point is D and this is E. Okay. The measurements they've given me AD, which is 8 inches. They've given me ED, which is 5 inches. And they've given us me CB, which is 7 inches. And they're saying, okay, so first of all, if I was to draw these separately, which I want you guys thinking about, all right, here is my small triangle. How many of you guys see that? Okay. Here is my big triangle. How many of you guys see that? Okay. So if I was to draw these separately, I'm just going to draw them next to each other. They might be a little bit smaller than they appear originally. So let's say this is our small triangle. This is AED. What is this measurement right here? What is this measurement, Christian? That's 5 inches. What is this measurement right here, Christian? This is 8 inches. You guys cool with that? Okay. Now I'm going to draw my big one. And we're going to do the same thing. This is the most important part, is understanding this. So this is ACB. Someone tell me, what is this measurement right here? Drew? This is 7 inches. What is this measurement from A all the way to B? Abby? Yeah, so I'm going to call this little segment here X. How many of you guys see that? Because I don't know this little tiny segment. So this big long side must be 8 plus X. Can you guys see that? How many of you guys are cool with that? Okay. All right, so now they tell us, substitute the values. So they tell us for part A, we want to do the proportion AD over AB is equal to DE over BC. So they're using sides from the same triangle to create our fractions. So AD is 8 inches. Oh no, I take that back. They're using corresponding sides. So AD, its corresponding side is AB, which is 8 plus X. If you did not have this, you're writing this down, please, because this is what I will give you on a test, by the way, is a problem just like this. So these two are corresponding sides. I wouldn't give you the proportion. You'd have to come up with that on your own. And by the way, you can't use parts of sides in a proportion. You need full sides. So I just can't use X by itself. Everyone look at the board and understand that. Do you see X is this small part? How many of you guys agree that you see X is this small part? It cannot be used alone as a side because it's not a full side. How many of you guys see that this is not a full side to a triangle? So I cannot use that. I need the entire sides. All right, so I have 8 over 8x is equal to 5 over 7. 5 over 7. Questions so far? Okay, so now I'm just going to solve this proportion for part B. You guys all know how to do this. What do I have to do with my 8 plus x when I do my cross multiplication? Alex, you better button it up. What do all the gentlemen need to have their top buttons buttoned? Well then, guess, your mom is the sweetest thing in the whole world. I guarantee you she will replace that button. Because the next time I see it, I get to give you a lunch detention. Do you know what I mean? So find a solution to that problem unless you want to spend some quality time with me at lunch. Okay. What do I need to do with my 8x before 8 plus x while I'm doing the distributive property? Go back in your homework. We had problems just like this the night before. What has to happen with that 8 plus x when I do the cross multiplication? Nathan? You have to put it in parentheses. Because I need to multiply that 5 by the 8 times 8 plus x. So in my cross multiplication, I have 5 times 8 plus x is equal to 8 times 7. Nathan, go get a piece of candy from my bag in there for being so nice to answer my question while the rest of you guys just sit. No, just do it nicely without peacocking. We don't need any peacocks in here. All right, so from here I have to do the there's a plastic bag right next to my jar. Yeah. Unless you want something from the jar. So I have to do the distributive property. 5 times 8 is 40, plus 5 times x. I'll take it away. Thank you. Plus 5 times x is going to be equal to 56. And then I just finished solving that. So I have 5x is equal to 16, divide each side by 5, and x is equal to 3.2. How would I find the area of triangle ABC? For part C, they told us to find this. So that means I have 8 plus 3.2, which gives me 11.2 inches. How would I find the area? How am I going to find the area of ABC? Kate? Yep, I need to do 1/2 base times height. So I know my base, I know my height, I can use my formula. All right. This is definitely a problem I would give you on a test or a quiz. It incorporates several different things together. What else can I do for you guys from your homework before I move on? Christian? Yep. Just identifying corresponding sides? That's all that was doing, was identifying corresponding sides and identifying corresponding angles. That's all that was. Do you need me to do that? The angles. Remember we talked about corresponding angles. It's the angles that go together. They're angles that are in the same location. Yes. What else can I do for you guys? All right, put this away, get your notes out. Come on. Okay. So what we are doing today, God bless you, is we are talking about similar figures when it comes to indirect measurement and scales. All right, so today's the 13th. We are still in 4.2. So 4.2 continued. We're talking about proportions and indirect measurements. And scales. Again, we did this last year, so this is not new to us. It's just remembering how to do it. All right, indirect measurement means that we are going to use shadows to create similar figures from objects. All right, so let's say we have this person standing on the ground. All right, we have the height. We have this building. I'm going to make the building a little bit shorter, just so this shadow works. I have the sun shining down. On both of them at the same angle. So these are the sun's rays. So these right here are like the sun's invisible rays coming down over your head, creating a shadow. And our shadow, these are my shadows. Do you guys remember doing this last year? All right. Yes. Well, great. I'm doing it again right now, so you're going to get it now. So what I have is, I have the height of the person. Let's say the person is 5 feet tall. Come on, don't look around. Just look what I'm doing. I have the height of my person, which is 5 feet tall. And let's say that her shadow is 3 feet long. Well, if we take a look at what I have now created, so what I've created is this triangle. This is my woman's triangle. That's 5 feet high by 3 feet wide. I've created a triangle. All right, I have the sun's rays that kind of come down to create that. Just put your hand down. To create that hypotenuse, I have her height as one side of the triangle and the shadow as the other. And they create this right triangle. All right, and I will do the same thing for my building. So my building's shadow, let's say the building's shadow is 10 feet. And I want to find the height of the building. So again, I've created this triangle between the building's shadow, and the sun's rays. So I've created this building's triangle. All right, and these are similar triangles. Triangles that I created are similar triangles. Well, we know the shadow of the building is 10 feet. We do not know the height of the building. And now we can use proportions to find the height of the building. Christian. How do I what? I've given you the stuff in pink. They're going to give you 3 of the measurements. And they're going to say, find another measurement. Find the missing measurement. So I'm telling you the height of the woman. I'm telling you the shadow of the woman. I'm telling you the shadow of the building. I want you to find the height of the building. So all of you do this. Solve this problem right now. You all should be having your calculators. I have told you guys to come in immediately and grab your calculators. So if you don't have your calculators, go get them. The moment you walk in, grab your calculators. The list is right there. Know what calculator number you are. Please take only your calculator number. If there's an issue with your calculator, I need to know right away what the issue is so I can figure out what the problem is and whose problem it is. Please do not mess around with the settings on my calculators. Well, you can darken the screen, and people mess around with that, and it's hard to get it back. So just don't mess around with my calculators. Yes. It's all right here. All the information's right here. 10 feet? Lily, it's right here. Come on, get moving. Christian, don't mess around with my calculator. I don't know why you have her calculator in your hand. Stop messing around and get going on this. You are solving this problem. Somebody write a proportion for me on this. Annalisa. How many of you guys agree with that? All right, who had a different one? Melissa? How many of you guys agree with that? All right, those are the two possibilities that you could have with regards to how we set it up. How did Annalisa set hers up? What are her fractions using to, what is she using to create her fractions in that first one? Nick? She's using her corresponding sides to create the fractions, which means the numerator needs to be from the same triangle, the small one, or the woman. The denominator needs to be from the same triangle, my building. Who did the second one for me? Melissa, was that you? What did Melissa use to create my second proportion? What did she use in her fractions? Come on, I need you guys understanding that. What did she use for her fractions? Lily? Yeah, so she's using the measurements from the woman to create the first fraction. She's using the measurements for the building to create the second. All right, the other way that you could do this is you could use both of those same, but they could be the reciprocals of both. I could do 10 over 3 is equal to x over 5, or I could do 3 over 5 is equal to x over 10. And if you notice, when we do the cross, whichever one you did, when you do the cross multiplication, you're going to get 3 times x is equal to 10 times 5, no matter what. So I have 3x is equal to 50. I divide both sides by 3. What did you get for the height of your building? Nathan? Repeating, right? So 16.6 feet. All right, let me give you guys another one. Raise your hand if you have any questions so far. Yes. You need to create your similar triangles. I'd like to see your similar triangles. So whether you do it up here, if they give you the drawing, you're drawing it, or if they give you like I'm going to do right now, you're going to draw it. Kaylee. Do you see this right here? So what do you think I want to see? That. I want to see that. All right, so let's say that a flagpole is 36 feet tall and has a shadow of 102 feet long. What would the shadow of a man be who is 6 feet tall? So I want you drawing what this is going to look like and then solving it, please. I want you drawing what this is going to look like and then solve it, please. Try to do this on your own. God bless you. Try to do this on your own. Use your notes of what we did in the first one. And then if you have questions, you can answer someone once you've asked someone, once you've tried it on your own. The sun is just creating this shadow. It's the angled side always. It's just what's. Have you ever stood outside, Christian, and you see your shadow? Okay, so that's the sun behind you, kind of shining down over the top of you, and you're creating the shadow. So the sun's rays is just that angled part coming off your head down. It's like an invisible line. It's creating that angled part. Do you understand? Okay. Why don't you look and see what people are doing? Why don't you look and see what we did on the last one? Can you do that for me? So here is the drawing or something like this that you should have. Here's my flagpole. It's 36 feet tall. Do you understand that, Christian? Okay. The sun shines down. Do you understand that? This is like the sun shining down over their head. This flagpole creates this shadow on the ground. Do you understand that? Okay. The sun shining down on this guy that is 6 feet tall, this is his height, it also casts this shadow on the ground. I don't know how long the shadow is. Here are my similar triangles. So it says, what would the shadow of a man be who is 10 feet tall? 6 feet tall. Here is the 6 foot tall guy. Here is the shadow. I don't know the shadow's length. So here is a picture of what is being described. Questions on this picture? All right. Somebody write my proportion for me. Come on. All of you should be able to do this. Someone write a proportion for me on this. Ryan. Equals. Yeah, so 36 over 102, 36 and 102, that's from the flagpole. And each of these things, each of the fractions are being made by corresponding sides. Somebody write a different one for me. How else could I have structured that? And my denominator is from the man. Somebody write that in a different way. Kate? Yes. So here, Kate used each figure's sides to create the fraction, which means my 6 and my 36 better be corresponding sides, and the x and the 102 better be corresponding sides. You do not need to know how to do both of them. Whichever one of those makes sense to you is what you're doing. All right, somebody do my cross multiplication for me. Nick? No, I'm not dividing 36 and 1 and 2. I mean, I could divide out common factors between these, but I just want you to do the cross multiplication. I'm not doing this division. Okay. Nick, all of you, to solve proportions, you're using cross multiplication. Always. That's what we're learning in this section. You are always using cross multiplication to solve a proportion. On this 36 over 6, I could divide out common factors between that and get 6 over 1 and simplify that. That's fine with me. I could divide out common factors between the 36 and the 102 if you want to. All right, I'm not on this because I want you guys to see that these two are going to be the same. I'm not doing the division of 36 divided by 102. Which shouldn't be an O. That's something that's what we've been doing for the past 2 days, is solving proportions using cross multiplication. All right, so I need you guys to put a big fat note on here. If you didn't know that, I need all of you to put a big fat note. Use cross multiplication to solve all proportions. All of them. Always. So somebody do the cross multiplication for me. Brendan. 6 times 102 equals? Excellent. 36 times x. What is 6 times 102, Brendan? 612 is equal to 36 times x. Now what? And what do you end up getting? 17? So 17 feet. So I'd say the flagpole's shadow is, thank you. How about you raise your hand rather than just saying things out loud? The man's shadow is 17 feet long. Okay, so this is indirect measurement. All right, let's talk about scales. Any of you that's ever looked at a drawing, looked at a map, I know you guys have looked at maps in Mrs. Bajungan's room. On a map, for you guys to use a map, we have what's called a scale. That means I have something like 1 inch is equal to 100 miles. That would be a scale. So what a scale is made up of, just to remind you, a scale is made up of that 1 inch is a measure on the map or drawing, because we use these for drawings as well. And the 100 is our actual measure in real life. All right, if I had something on a drawing, this might be from a map. If I had something from a drawing, it might be like 1 inch is equal to 5 feet. Here is my drawing measure. Here is my actual measure. So the big thing is when we are given a scale, the scale is your known fraction. In a proportion. Always use that as your known fraction. So let me give you an example of what I'm talking about. Again, we've done these before. So let's say the scale on a map is 1 inch and then colon 10 miles. So that's the same thing as 1 inch equals 12 miles. All right? Approximately How far is it from Detroit to Lansing if the map measures 18.25 inches. Alright, so I have our scale relating inches to miles. I have an amount of inches. I just don't know my number of miles. So this is a proportion. So 1 inch over 10 miles equals. Now, your 1 inch came from the map. The 10 miles came from our actual. So what that means is I need to have my map measure in my numerator in my unknown fraction, and my actual measure in my unknown fraction is my denominator. So somebody set up my unknown fraction for me in my proportion. Lily? Yep, 8.25 over x. This would be inches. All of you solve this, please. Using cross multiplication. How many miles is it from Detroit to Lansing in actual life? Drew? 82.5 miles. You guys cool with that? Alright, that's it. Please use your notes as a guide. Clear your calculators before you put them away for me, please.